Hey guys, it's Mr. Ross again. This is Complex Numbers Day 2 for Week 3. Hopefully you've already watched the video for Day 1 about radical equations. And then Day 3 will simply be just some review problems from Day 1 and Day 2. Day 3 and 4 will be the review. And then Day 5 will be the assessment. So please make sure you look back over these two videos if you have any questions after these videos. Please make sure you join a Zoom chat and I can answer your questions. So as you can see, complex numbers means we have I again. So the biggest thing here with a problem like this is that negative sign out in front. So the negative simply means that you have to distribute it out. So we're going to have negative 3 plus 5i. That doesn't change. Now the negative times a negative makes it a positive 2. And then now we have a negative 8i. We take our I values and we can combine those. So positive 5i minus 8i will be negative 3i. And then negative 3 plus 2 is negative 1. And that is your answer. This is called a complex number because it involves an imaginary number and a real number. So what you want to do is list the real number first, that's the negative 1, and list the imaginary number second, which would be the negative 3i. Alright, number 2 will be the same type of problem. In fact, this will be a little easier because this is the plus sign, so that means you don't have to distribute out any negatives. So you just simply drop the parentheses. 5 minus 3i minus 7 minus 3i. In the last problem, we had to distribute out a negative, but on this one, again, this was a positive number, so we don't have to worry about that. Alright, so we just combine like terms. So we got a negative 3i and a negative 3i. That gives me a negative 6i. And then we have a 5 minus 7, and that's negative 2. Again, the real number, negative 2, goes first, and the imaginary component, the negative 6i, goes last. So I think most of you guys will find today's assignment for Day 2 easier than the first day as far as the workload. Alright, as you can see, these are two parentheses written side by side, so that is a FOIL problem. So 6 times negative 8 is negative 48. 6 times negative 8i will be negative 48i. I don't know if you noticed, but our answer is negative 96. And my two parts right now look nothing like that. So that must mean a number of different terms cancel out. So negative 6i times negative 8 will be a positive 48i. And those are opposites, so those cancel out. And negative 6i times negative 8i, negative times a negative is a positive. Alright, 6 times 8 will be 48, and I times I is I squared. So, we got negative 48 plus 48i squared. That's still not the answer of negative 96 because, if you remember, I squared is negative 1. And then that means it's negative 48 plus another negative 48. And that is how you get the answer of negative 96. So, key takeaway on this problem is remembering that I squared equals negative 1. Alright, don't forget that. You're going to need that again. Okay, number 4 is really just the same type of problem. The only difference is they wrote a little squared there, so that just means it's 2 plus 3i times 2 plus another 3i. So this is simply another FOIL problem. 2 times 2, we got 4. 2 times 3i, we got 6i. 3i times 2, so we got another 6i. And then we got 3i times 3i, which would be 9i squared. Alright, the two 6i's are like terms. That gives me the 12i, which you can see as part of your answer. Alright, now remember, what was I squared again? That would be a negative 1, so it's 9 times negative 1, which of course is negative 9. Alright, then at this point, you've got to isolate your like terms. So you got your 4 minus 9. That gives me the negative 5. And there's no other I value, so it stays as 12i. Now, please remember you cannot combine those two together. Those are not like terms, so don't write down 17i or 7i or anything silly like that. Alright, now, 5 through 8 deals with division. So, on a problem like this, the problem is you cannot have any type of root on the bottom. So you have to remember that I is equal to the square root of negative 1. So that literally means you have a square root on the bottom, which is not allowed. So what we want to do is get rid of that problem. So we want to get rid of what's causing the issue, which is the I value. So we want to multiply by I. Alright, so that means it'll be 3 times I, so that's 3i. And it'll be 7i times I, which will be 7i squared. Now, what is I squared? That's negative 1. So you end up with 3i over negative 7. And as you can see, that is equivalent to our answer. 3i divided by negative 7 is the same as negative 3i over positive 7. Okay? One quick thing I can show you on this problem is some students will opt on this problem to multiply by 7i instead of just I, which is fine. You're just going to have to divide. 3 times 7i would be 21i, and then 7i times 7i would be 49i squared. So that'll be 21i over negative 49, because again, I squared is negative 1. Now, what you would have to do at this point is to take 21 and 49 and divide them by 7, which would give you 3i over negative 7. So you end up with the same answer. It's just you'd have to do an extra step of simplifying. So that's why I would just multiply by I instead of the 7i. Alright, number 6. Same type of problem. Multiply by what's causing you the issue, and the issue is the I value, not the negative 3, just the I. So when I multiply by I, I'll get negative 9i over negative 3i squared. Because remember, a negative times a positive will be a negative. Now, I times I is I squared, so that means it's negative 9i over negative 3 times negative 1. Because remember, I squared is negative 1. Negative 9i over negative times a negative is a positive. So, of course, 9 can be divided by 3. Since it's negative, it'll be a negative 3, and then there's your I value. Again, this is only possible because these two are actually divisible. 9 divided by 3 is 3. In this case, a negative 9 divided by 3 is negative 3. If it had been 8, then I would not have been able to do that last step. Okay? 7 and 8 are basically the same type of problem. This should look familiar to you. You cannot have an I on the bottom, and this is written with a plus or minus in between, so what this is a conjugate. So if you remember from last week's lesson, you have to do the conjugate, so that would be 2 plus 4i. Remember, you only change the sign in the middle when it's a conjugate. So now we need to multiply. So unfortunately for us, that means some more work because we're going to have to use FOIL. Alright, so we're going to have a lot of work here. Negative 4 times 2 will be negative 8. Negative 4 times 4i will be negative 16i. Negative 4i times 2 will be negative 8i. And negative 4i times positive 4i will be negative 16i squared. Okay, I squared again is negative 1, so that makes that a positive 16. Now we got a 16 and a negative 8, so that makes it a positive 8. And then negative 16 minus 8i will be negative 24i. So there's our numerator. We'll switch colors here and go to the denominator. Now remember, with your denominator, you shouldn't have any more square roots, or in this case I values, on the bottom. So we're going to have 2 times 2. I'm going to go ahead and write it down again. That's what's going to be our bottom one right here. So we got 2 times 2, which is going to give us 4. 2 times 4i, which will give us 8i. Negative 4i times 2 will give us negative 8i. And as you can tell, those cancel out. And negative 4i times positive 4i is negative 16i squared. Again, negative 16 times negative 1, because I squared is negative 1, is positive 16. Bring in your 4, and 4 plus 16 is 20. So now I'm going to have 8 minus 24i over 20. Now that's not the answer that we see at the top here, so that must mean I can divide. What can go into 8, 24, and 20? The largest number I can think of is 4. So I'm going to divide everything you see there by 4. So 8 divided by 4 is 2. 24 divided by 4 would be 6, so that's a 6i. And then 20 divided by 4 would be 5. So this will be my simplified solution. And as you can tell, that is the solution that we have. So 2 minus 6i over 5. Last but not least is number 8. As you can tell, you have a plus minus on the bottom, in this case a minus, so that means you got to get rid of it by using the conjugate, so that's going to be 3 plus 2i, and 3 plus 2i. Alright, the top on this one, or the numerator, is actually really easy. 1 times anything is going to stay the same, so that means we're going to still have a 3 plus 2i. Now on the bottom, remember, we shouldn't have any more roots left when we're done. So we're going to do 3 times 3, that'll give us 9, and 3 times 2i, that'll give us 6i. Now we can't have any i's on the bottom, so the next one will give us what we need, which is the opposite of that, negative 6i. So those, of course, cancel out. And then negative 2i times positive 2i is negative 4i squared. And again, the I squared is negative 1. So a negative times a negative is a positive, so we end up with 9 plus 4, which we know is 13. So, final answer on this one will be 3 plus 2i over 13. Now, unlike the previous problem, which I'll scroll back over there for you, this was the previous problem. As you can see, it simplified down because everything was divisible by 4. But on this one, nothing can go into 3, 2, and 13. So that ends up being our final simplified answer. Okay? So, the only assignments left for you this week would be to do the review, which will just be from problems from day 1 and day 2. And I set up a couple days for you to do that. And then the last day this week, I want you to do the assessment, which is just going to be seeing how you guys understand day 1 and day 2. Alright? Again, watch these videos first. If you have any questions or concerns, please feel free to reach out to me through email. And of course, I have my Zoom chats available. Thank you guys, and have a good week.